South Pretoria. The title of my research is the physiological impact of heat stress conditions during anthesis and pollination in domesticated sunflowers. So a warming climate has been reported in the last decades across the globe as warming, as the temperatures, annual temperatures are increasing due to the global warming. So these temperatures are expected to increase by 2.0 to 4.9 degrees Celsius. 2.0 to 4.9 degrees Celsius, increasing then the global temperatures. The increasing temperatures causes the frequent occurrence of the natural heat wave conditions, which are defined as an increase of 5 degrees Celsius above the average temperature of an area, a certain area, for at least a minimum of 3 consecutive days. So plants are known to have a lot of impacts during the reproductive stage, as they impact on its pollination and yield. Generally, a sunflower is known to be a hardy plant because it can withstand harsh environmental conditions. But it is also known that we don't know how the sunflower responds to heat stress, and as the duration of the heat stress and its exposure may affect the sunflowers. It is known to have a temperature threshold of 26 to 29 degrees Celsius. So the study is looking at what happens then beyond those temperatures. Okay, my study was deduced from these 2 studies, and their focus was on normal and cooler and natural temperatures. So the first study was by Crew et al. 2021. They looked at the style elongation and the pollen emergence. So they found that at higher temperatures, style elongated faster, and at higher temperatures, pollen emerged quicker than at lower temperatures. And the second study is by TIMELAPSE et al. 2016, and they were looking at pollinator visits. So at they had east-facing plants and west-facing plants, and then they found that the east-facing plants had more insect visitors than the west-facing plants, and they decided to then heat the west-facing plant, and they saw that there were more than visitors coming to the west heated facing plants than the west non-heated plants. So they came to a conclusion that some pollinators actually prefer warmer sunflower heads, and temperature does play a huge role in the visitation pattern of the pollinators. So my study is now looking at during anthesis and what then happens beyond when temperatures are higher. Okay, the study aims to answer these questions. The main question is, how do heat waves and heat stress affect the timing of late-stage floral organ development, pollinator visits, and the pollination in sunflowers? And there is 4 sub-questions, which are, how does the initial heating affect the timing of the pollen emergence in sunflowers? The second one is how it affects the timing of the pollinator visits and the total count of the pollinators. Third one is how it affects the rate of the style elongation, and the last one is the stigma receptivity. And this is how I conducted my research. We planted the sunflowers in the field, and at anthesis, that's when we did our experiments. We have 4 experiments to be discussed today. The first one is the time-lapse photography. This looks at the pollen emergence. So we had 2 tripods, the one with the heated and the one unheated, and we mounted the time-lapse cameras on. This was to check for the timing of the pollen emergence, and this was compared between the 2 conditions, and the pictures were taken every 15 minutes before sunrise. The second one is the insect visits. With this one, we also had tripods with video cameras on, and the one was heated and the other one was not heated. And we were just monitoring insect visits for at 5 time points. We took 20 minutes videos at each hour. And the third one is the style elongation. So with this one, we also have the sit styles from the heated plant and the unheated plants, 5 each. And then we'll lay them down in a shape like that, and then take a photo, and then which we'll use to measure the length of styles later on using Fiji. And the last one is stigma resistivity. We used microscope slides to put hydrogen peroxide in, and then we'll wait for 3 minutes and then take the pictures and count the bubbles on Fiji as well. The yellow arrow is showing the bubbling of the stigmas. And with all these experiments, the temperatures were noted on all the time points of the sampling. Okay, so these are the results. The first one is for the style elongation. So my results are divided into 3, the sunny and overcast and the heat wave data. You'll note that the overcast, the heat wave is plotted with the sunny weather. This was just used as control. So with the sunny weather and the overcast weather, you can see that the style elongated faster when they were heated than the unheated ones, and this is seen as early as time point 0.5. Whereas with the natural heat wave, the style still elongate faster during a natural heat wave, but the differences were not significant. And you can see that with the sunny days, they elongate and they eventually catch up with the heated ones and become even longer. This means that during a heat wave, styles eventually shrink. The next one is a timelapse photography. This looks at the pollen emergence. So with the sunny weather, pollen from the heated plants emerged at the same time as the unheated, but it was emerging at a quicker rate than the unheated ones. And the overcast, it emerged earlier with the heated plants, but they were emerging at almost the same pace, unheated. And with the natural heat wave, you can see that it emerged at a much quicker pace with the natural heat wave than the sunny days, as much as they started earlier. And the next one is the insect visits. With the insect visits, there is with the sunny weather, there's not much of differences that you can see in the pattern. This could be because of the light, but you do see differences even though they're not significant with the overcast. It might be because we needed maybe to get more samples, more replicates of the data to get significant differences. But you can see that with the heated, there's more insect visits than the unheated ones. And with the natural heat wave, there is an obvious significance with the number of insect visits that come to visit during a heat wave data. And the last one is the stigma resistivity. With the overcast and the sunny weather, we see a decreased stigma resistivity from the heated plants than the unheated plants. And with the heat wave data, you see there is a slight increase. It might not be significant, but there is a slight increase. We'll need to do more tests to conclude on this one because it might be that the tests maybe did not work well in the field, and we'll need to do more replicates to conclude on that. Okay. In conclusion, under both artificial heating and heat wave conditions, styles elevated faster than when unheated. And then pollen emergence was partially temperature regulated, but humidity or light may also play a role. Insect visits are increased and commence earlier at higher temperatures, but other factors might also be involved, such as light. And then the last one is that artificial heating decreased the stigma resistivity. The natural heat wave showed an increase in stigma resistivity, but more tests need to be conducted. Thank you. That's the end of my presentation. I would like to thank my supervisors, Dr. Crew and Dr. Fori, the CFB team, Lisi Hoyle team at the Experimental Farm, MPTI and Fort Baker, and all my finding points. Thank you.